In this lesson, we're going to be working with the following topology. Two Nexus 5548s configured by a trunk link on port Ethernet 1/25. Let's go ahead and take a look. Here I have my two Nexus switches. In this lesson, we're going to configure the spanning tree protocol to run RPVST+. First thing I have to do is go into global configuration mode, which is where I am already. If I do a show spanning tree, I can see that right now I'm running MSTP and not rapid spanning tree. If I want to change that, I simply have to type in spanning tree mode rapid PVST and press enter. Now if I do a show spanning tree, I can see that my protocol is rapid spanning tree. I'm going to do the same thing on the other switch. As you can see, by making that change, I've caused a disruption in my spanning tree. I'm already in global configuration mode, so I want to type spanning tree mode rapid PVST. If I do my show spanning tree, I will see that the spanning tree protocol enabled is indeed rapid spanning tree. Other options I might want to configure are going to be my spanning tree VLAN, because this is a per VLAN spanning tree. I pick the VLANs that I want, maybe 1 through 10, or maybe 1 through 4093, and I can set a priority for these VLANs individually. I can set this one by one or as a group, or I can simply just say, I want this switch to be the root. Let's make it the primary. Press enter. Now this switch will be the primary root bridge for VLANs 1 through 10. If I do a show spanning tree once again, I can see that this bridge is indeed the root for VLAN 1. In regards to both MST and rapid spanning tree, there is a setting that I may want to explore. Because spanning tree has been around for such a long time, when they developed the protocol, they didn't necessarily see that someday we would have 40 gig and 100 gig connections. So the port costs that spanning tree uses to calculate the best path to the root are limited to 10 gig. So a 10 gig port has a cost of 2, and a 20 gig port has a cost of 2. A 40 gig port has a cost of 2. So all of these ports, once you go past 10 gig, have the same cost. So spanning tree no longer has the ability to determine which are the best links and may choose a suboptimal path to the root. How we change that in both MST and in rapid PVST is by changing the path cost. So if we type spanning tree path cost method, there are two methods. The first one is short, which is what's currently used by default on the switch that has the limitations that we described. The second one is long, which is something that you want to enable if you're going to be using any ether channels or port channels with more than one 10 gig link. I'm not going to enable this here today. Finally, the last configuration that we're going to cover that we can apply to both rapid PVST and MST is actually changing the spanning tree port cost of the individual ports to steer traffic one way or the other. In order to do this, we would go under the individual port or range of ports that we want to modify the cost for. In this case, I'm going to go to Ethernet 1/1. If I want to change the cost, I would type spanning tree cost and then assign a cost. The higher number makes this look like a less desirable port. Please join me for our next lesson, configuring spanning tree port types.